All right, quick video on the distributive theory of multiplication. And I made this as simple and crude as possible on purpose. I have a lady that, if I asked her to, she'd knock this out and make a beautiful graphic for me. Um, but you don't need to. It's this simple to get understood. Here's the blocks. So what do we have here? We have fours. And what I'm saying, and this is like entirely too complicated, is that uh, hmm, 4 taken 5 times, and the pattern is across and up for multiplication and across and down for division, but across and up. So I have 4 taken 5 times. And that's the same thing. In other words, 4 times 5 is the same thing as 4 times 2 plus 3 times 4. Wait, let me say it right. 4 times 2 plus 4 times 3. There you go. All right. But do you see the 2 and the 3 and how that makes 5? And how does it get simpler than that? It doesn't get simpler than that. We got to complicate things with all these symbols and everything. But there it is. Look, it's 4 2 times and then 3 more times, which is the same thing as 4 times 5. And there it is. 4 2 times and 4 3 times, which is just 8 plus 12. And that's the same thing as 20, because 4 times 5 is 20. That's it. We're just making 20 really complicated. But here's a even simpler drawing where you don't have to make all the dots. And you just blend uh, image and symbol. So there's 20 and 8 and 12. That's what you got there. And see, now here's the other thing. Um, Even more math for the little ones. If, let's see, this whole thing is 8 and one side's 2, the other side has to be 4. If this whole thing is 12 and one side's 3, the other side has to be 4. So, and 12 is a fun number. We're going to play with 12 a little bit in a minute here. Why? Because you're going to flow from one thing to another. You do this with little kids, and they look at you like you're silly. Of course, it's the same. We just put a line there. What? What's the big deal? And look, here's the symbols that describe what's going on here. It, no, I've seen students have a difficult time when this is introduced with symbol only. All right, so let's get a little more complicated, right? Like this one, no problem, but let's get a little more complicated. Oh no, there's an X in there. All right, so let's blow that too much. Okay, so 3 taken I don't know how many times and 3 more times. So 3 this way and x plus 3 this way, which gives us 3x and 9. And all we're saying is we're distributing, of course, because look at our rectangles. How could this one have a different side than this if it's 2 rectangles? And that's what you're describing here. 3x, right? We're distributing the 3 across this binomial. Um, Look, it's 3 of them and 3 of them. Yeah, that's it. And that gives you 3x, and that just really drive home the point. It's 3 times the x, and look, it's 3 times the 3, and now we can go all the way to 3x plus 9. This intermediate step I've seen make a difference with many students in the upper grades. Just, oh, like obvious, but still, just do the step, because most people just go from here directly to there. Of course, because 3 times 3 is 9, we know that. Okay, let's get even more complicated. Now see, when you teach with little children, you want to start in the concrete. Here I'm going with symbols and drawings, but what I should be doing is starting right here with base 10 blocks. Turned on the smooth side because algebra is a smooth subject. Now, here's a couple drawings. There it is in color. There it is just in black and white. And here we are describing what's going on here. And what's going on here is distribution. And you will not see a pox on you if you wanted to see foil. But here it is. The first ones. Oh, yeah, as I'm going across, right? It's like up, across, and up, across, and up. The first one times the first one, yeah, the first one times that one is x squared. And then what? And then I go across that one, and so first, inside, outside last. Yeah, so then I go, there it is, 1x. And then, let's see here. Then I got to go up this way and count these guys. And, oh, look, it's 1x, and there's the 1. There it is. So 2 rectangles, basically. See, over here, we had 2 really simple rectangles, and then we got a little more complicated. And then we got really complicated, but not really. Oh, and by the way, why do they call them quadratics? 1, 2, 3, 4, except for these 2 are the same, so we combine them. See it all there? All right, I hope this completely removes any questions you have about distribution. Because what happens a lot of times, especially when they see something, and I do this on purpose, like this, is they'll come up with x squared plus 1, because they just do this, and they forget all about these 2 guys, and they just count this and this. All right, so like I said, distribution, no problem, quick, easy. With little children, you could just do this part, skip this part, and this part, and then I'll tell you what, let's go build a pyramid, because we'll talk about 12s. And look, oh, this kind of 12 is different than that kind of 12. That other 12 was 4 by 3, and this one is 1 by 12. And look, I could take 2 6s and put them side by side, and that'd be 12. So we see that 12 can take multiple shapes. We can reshape 12. But anyway, we're building a pyramid here, just for fun. Why? Because we were talking about 12 a second ago up here. So let's play with 12. And so here we are playing, and made a really cool pyramid. And oh wait, I got carried away here. So made a really cool pyramid here. So many questions. How many 12s is this? How many 12s is this? Let's call it all the 12s. And see, it's way more fun when you got lots and lots of 12s. I don't even remember how many 12s this was. You can count them yourself and count by 12s. And you can see down here. You may have to extrapolate a little bit, but there it is. And then the question was, what if I cut the 12s pyramid in half? How much would it be? So I did all kinds of math, counting 12s there. Okay, so then we could fool around. Just next thing. Oh, make some square numbers in the trace. And they're in a situation where they cannot fail, because you can only build square numbers when you build them like this. And we can get some multiplication going on here. And see, start off really easy. For the little kids, this is a huge amount of counting. So maybe you just do these, and then you just do these for them. But 3, 6, 9, that's easy. 2, 4. And you can see that that's 2 2s. And this is, everyone knows that one by heart, right? 2 times 2 is 4. 2 plus 2 is 4. Okay, you got to know 15 times 15 is 225. Just as easy. 19 times 19 is 361. I don't know, what, 12 times 13 is 156. You just know them, because you played with them so much. Okay, we make some squares in the trays. Well, that's kind of boring. Let's take it and make a super duper groovy temple going on here. So what we've got is this, and he even built a guy there. So we were fooling around with 13 square, which is, oh look, 1, 6, 9. Easy to see. Any little child can square numbers and count them. And in fact, this one's easy to count, because 1, 6, 9. This one is way harder to count, because you got to count all those 9s. And that's 81. Oh my goodness. So you count them out. And then what? What if I added these guys together? All kinds of things you can do. And we could squish this thing down and make a cool design out of that too. Oh, I should have put that slide in here. Maybe I'll go back and get another one. But anyway, the idea is you just play. It took a while to build this, even though there were lots of them building it. It still took a while. And then it took a long time to count all those 12s by 12s. And they figured out some fast and efficient ways to count them. Because you multiply the 10s and you multiply the 2s and you add them together, and there you have it. So they just counted out how many 12s they had built. And then we talked about cutting it in half, and divide by 2, and having fun just fooling around with a 12 pyramid. And like I said, you could start off right here and just talk about distribution really quickly, and they're going to go, no duh. And then, well, since we were talking about 12, right, let's play with 12s. And then we could just as easily play with 8s. And 8s are not as fun to build as 12s, but they're still pretty cool because there's more combinations um, when you play with these guys because you've got a longer block, right, or a longer set. So it makes it more fun. And the only rule that I put together for this pyramid was that you could only use 2 blocks. That's it. You could use 10 and a 2. You could use. You couldn't use 10 and 2 ones because that's 3 blocks. But all the rest of them are all the add-ins for 12. All right. CroutonAlonesHouseOfMath.com for more. Just fooling around. Distribution is super easy. Why not, since you got that explained, why not do some other stuff? Because it should take you 2 minutes, and then you can come back later and do a more complicated lesson, and then you can come back another time and do a more complicated lesson than that. Or if you've got older students, maybe you want to start here and you work your way up. Now here's the problem: is a lot of you want to start here. And it looks confusing. And then they remember this rule: first inside, outside last. And then if they don't remember the rule or what it means, or if they forget the rule, they wind up with x squared plus 1, and they forget about the 2x. Because that's a really common error in algebra. So if you start here, okay, so that's like, okay, right? No cognitive load whatsoever. Okay, and then put the symbols in, okay, and get the blocks out. Whatever manipulatives you have. If you have only unifix cubes, get the unifix cubes out and get them all out. And yes, it's a pain because you got to get 20 of them out, and then you got to put them in rows. And these are super fast because it's just, 5 blocks. Okay, so, and then a quick drawing, and it becomes really clear that, 4 times 2 plus 4 times 3 is the same thing as 4 times 5. Super easy when they're older, and then make it a little more complicated, and then a little more complicated, and it becomes easy that you understand that you have to distribute over the whole thing. Everybody gets multiplied by everybody else. And then you could go to the next level, and I didn't do it here, where we take a binomial times a trinomial. But it's going to be the same thing, and when you have the blocks and get them out, you're going to need your basic operations pieces, or you know how to draw them. You'll be able to see very clearly that, once again, we're just distributing, and then we add up everything that's the same. So over here, this is technically x times x, and 1x and 1x and 1. Oh my. It seems to me that 1x and that 1x are the same thing as 2x. So let's put them together. And there it is. No confusion. But still, I know teachers, and I've been in rooms of teachers. I won't mention any names, but in various schools on Maui, but also all over the United States, 49 of them. And there's oftentimes when I ask the math teachers, raise your hand if you're a math teacher, why do they call them quadratics when there's only 3 symbols and that's a 2? Why do they call them quadratics? And most of them can't answer. And now you know. Look, 1, 2, 3, 4. That's why we call them quadratics. There's 4 numbers there. 4 kinds of numbers. But 2 of them are the same, so we stick them together. Okay. CroutonAlonesHouseOfMath.com. 4 more.